Hi there, it's Mrs. Arispe, and in this video I wanted to talk a little bit about using the difference quotient. So here we have the difference quotient. That's what we get when we take f of x plus h, subtract f of x, and then divide all of that by h. Notice this symbol says that h can't be 0, and that's so that our domain can be obeyed. We can't divide by 0, so that's all that says. So let's look at a couple of examples. First, it says find the difference quotient of this function f of x. Our first step in finding our difference quotient is that we need to find f of x plus h. Well, f of x plus h is what I get when I take f of x and replace that x with x plus h and evaluate. Remember this x plus h squared, that is a perfect square trinomial, and we are able to use our formula to evaluate that. Remember, the formula here would be using the fact that a plus b squared is a squared plus 2ab plus b squared. Okay. If I use this formula, a would be x, b would be h, and this becomes x squared plus 2xh plus h squared minus 2. So this portion is represented by this trinomial, and we still have minus 2 at the end. Now, normally at this point, we would try to combine any like terms, but none of these terms are alike. So now it's time to move on to plugging in f of x plus h and f of x to the difference quotient. So I'm going to start by writing my difference quotient, but I'm going to use the colors of f of x and f of x plus h that I used here, just to help us to see what goes where. So I'm going to take f of x plus h and subtract from that the function f of x, and then I'm going to divide all of that by h. So I took this formula, color coded it, and now let's write what that's equal to. Remember, f of x plus h, we just evaluated. So I have x squared plus 2xh plus h squared minus 2. I'm going to subtract from that f of x. Now remember, if you're subtracting an entire function, it's important to put that function into parentheses so you remember to distribute that negative to each of those terms. When I distribute that negative, this becomes f of x plus h does not change, so x squared plus 2xh plus h squared minus 2. Distribute the negative, minus x squared. Negative times the negative gives me plus 2 all over h. Now at this point, terms should combine and really cancel from our numerator. For example, I see that x squared minus x squared cancel, and negative 2 plus 2 cancel. And so all I'm left with is 2xh plus h squared over h. Now we have two choices. We could separate this into two different terms and then divide each term by h, or we can do what is called factoring out our GCF, our greatest common factor. If I factor out that greatest common factor, that's the biggest number or the biggest thing that these two terms share, that number would be h, because both 2xh and h squared are divisible by h. And then when I look at 2xh and divide by h, I'm left with 2x. So I'm going to multiply by what's left over, plus h squared divide by h. Remember, if we have the same variable and we divide, we have x to the n, divide by x to the m, we subtract their exponents. So 2 minus that silent 1 would be h to the first power. Now this is useful because at this point, I see that the factor h cancels from both the numerator and denominator, and my final answer would be 2x plus h. And that is the value of the difference quotient for this function. Let's follow those steps again. For this function, the difference quotient doesn't change, the process doesn't change, but if your function changes, you are going to have to work a little harder from time to time. You'll notice our function here was x squared minus 2. Here we have x squared minus 2x plus 7. Our first step is the same. We're going to start by finding f of x plus h, which means everywhere I have an x in f of x, I'm going to replace with x plus h. So I have x squared, so I'm going to write x plus h squared, minus 2x, replace with x plus h, plus 7. Now from here, I'm going to again apply the fact that a plus b squared is a squared plus 2ab plus b squared to this portion only. So I'm going to rewrite x plus h as x squared plus 2xh plus h squared. And in this second term, I'm going to distribute this negative 2 to each of these variables. So I can write minus 2x minus 2h. And then at the end, I'm going to write plus 7. If I can combine any like terms, I do, but it turns out with all these terms, there are no like terms. So let's move on to step 2. Now step 2 says we're going to take the difference quotient. We're going to plug in the values of f of x plus h and f of x. So I'm going to take f of x plus h. I'm going to subtract f of x and divide that difference by h. So that's the formula. So let's plug in what we have here. So f of x plus h, I wrote it in pink here, so I'm going to go ahead and write it in pink to the right. I have x squared plus 2xh plus h squared minus 2x minus 2h plus 7 minus, and remember we put parentheses around this f of x because we want to make sure that that negative is distributed to every term in f of x. So I have x squared minus 2x plus 7. And again, that is all over h. Okay. Let's distribute that negative to all three terms in f of x. Our f of x plus h did not change. But now we have minus x squared plus 2x because this negative negative becomes a positive, and then minus 7. Let's find those like terms and cancel them out. X squared cancels with negative x squared. I don't have a counterpart for 2xh, h squared, but negative 2x cancels with positive 2x, minus 2h, plus 7 cancels with negative 7. So what you'll notice is that every time these terms from f of x should cancel with terms from f of x plus h. And each of these leftover values have an h in them. That should happen every time. So I have 2xh plus h squared minus 2h all over h. And just like I did in the last problem, I noticed that because each of these terms has an h, I can factor it out and write what's left over. 2xh, when I divide by h, is just 2x plus, remember what I said up here about our exponents? H squared divided by h to the first would be h to the 2 minus 1, or just h. And negative 2h divided by h, those h's cancel. I'm left with minus 2. This h goes here. And the hope is if you do this correctly, these h's will cancel, and what is left over will be your solution. And that is the answer to finding the difference quotient for this function. So hopefully, if you work through this methodically, kind of slowly, you too will be able to find the difference quotient for any function.